Now, if we're ever going to be able to solve any sort of exponential equation, then we have to know what a logarithm is, and then to solve logarithmic equations, we're going to have to know a good bit about them, and that's what we're going to do here with properties of logarithms. And we have to remember the definition of a logarithm, and if we can remember that, then these properties of logarithms are actually pretty simple to learn. So first of all, remember what is a logarithm. So if I say log base a of x equals y, remember that is the exact same thing as saying a to the y equals x. And if you've seen any of my other videos, you remember the whirlwind property, a to that power equals that. Or log base a of this equals that, okay? But what you need to keep in mind here is when you're looking at a logarithm, right? So for example, let's say I take log base 2 of 8 and I'm trying to consider what this is. The question I'm asking myself is what power of 2 is 8? And since I remember that 8 is actually the same thing as 2 cubed, I can say that that's going to be 3. If you want to write it as an exponential, what we're saying here is that 2 cubed equals 3, right? We're saying 2 cubed equals 3, so that means a log base 2 of 8 is 3. So the reason I'm saying this is notice that what's popping out of this thing is the exponent. So the properties of logarithms operate very much like exponents. Let me show you what I'm talking about here. Let's list them out. All right, so for the first one, we have log base a of xy. And now what I'm thinking of is what happens to the exponents when I multiply two things together. For example, if I say x squared times x cubed, what do? I have to add the exponents together. So multiplication turns into addition when I'm talking about exponents, and that's exactly what happens with the logarithms. This is log base a of x plus log base a of y. All right, now in a similar way, we could take division. So I have log base a of x over y. Well, what happens when you divide with exponents? You subtract the exponents, right? So log base a of x minus log base a of y is the same thing as log base a of x divided by y. Division turns into subtraction, which is unusual at first, but then we remember we've seen this before with exponents. All right, now, so if I take log base a of x to the r power, so this time r is an exponent inside the logarithm, well, isn't that the same thing as saying, like x cubed is the same thing as saying what? X times x times x 3 times. This is the same thing as x times x times x r times. So if I use the first property, that just turns it into addition over and over and over of the same thing, and I'll have r copies of log base a of x. Okay, so this third principle here, I can take the exponent out. I can say log base a of x to the r power is the same thing as r times log base a of x. And that is an extremely useful property. All of them are, but this third one especially we use a lot. Okay, now I'm going to add a few other things we need to keep in mind that are just common things. You've seen them already, but a few other things to know. So first of all, if I'm talking about the domain of logarithm base a of x, that's going to be 0 to infinity. Okay, and the 0 is not included here. Okay, another thing is log base a of 1 will always be 0, regardless of what your base is, because a to the 0th power is 1. And then the third thing we should keep in mind is that if I have log base a of a itself, what power of a is a? Well, that's just a to the first power. Okay, so these are some things we need to know. Now, what we need to do really is practice using these principles of logarithms. So I'm going to go over a couple examples. One, we're going to pull them apart. The other, we're going to put them together. Your book may say that we're expanding and condensing logarithms. Let me show you. All right, so here we're going to use properties of logarithms to expand. And what that means is we want to pull these things, these logarithms, look, they're complicated expressions inside the logarithm. We want to pull them apart as much as we can using our three rules. All right, so for the first one, the first thing I notice here is multiplication. Remember, multiplication can be turned into addition. So I'm going to break this up into addition statements going across multiplication. So what I mean by that is I have log base 3 of 27 plus log base 3 of z to the 4th power plus log base 3 of the square root of y, right? Because those are the three things that are being multiplied across each other. And then hopefully I can simplify those even more. And you know what? I have an idea. Let's change square root of y, because remember, square root is actually y to the 1/2 power, right? Remember, the denominator of your exponent tells you the degree of your radical, so the square root of y is y to the 1/2 power. All right, now this first logarithm may trick us, but remember 27 is the same thing as 3 cubed. So this is the same thing as saying log base 3 of 3 cubed here. Okay, now I notice here the z to the fourth, I can actually pull out the 4, right? Because remember, our third property said that an exponent can be pulled out in front as a coefficient. And the same applies with the third logarithm. I have 1/2 log base 3 of y. So I've almost done it if I can just simplify that first thing. So remember what a logarithm is. For example, when we said log base 2 of 8, we said that was 3 because 8 was 2 to the third power. Here I have 3 to the third power. When I'm talking about log base 3, this simplifies to 3. In other words, you're asking yourself, what power of 3 is 27? It's the third power. So that whole thing just turns into 3, and then I have plus 4 log base 3 of z plus 1/2 log base 3 of y, and that's about as simple as it can get. We can't pull it apart anymore. We've used our properties of logarithms to fully expand this thing. I hope that makes sense. Let's try another one here in part B. We have log base a of the cube root of x y to the fourth over z to the 9th power. Okay, there's a lot going on here. What I'm going to do first of all is I'm going to write this as log base a of x y to the fourth over z to the 9th, all to the, remember, the degree of your radical is the denominator of your exponent, so this is the 1/3 power. I think it's useful to see it that way because remember, from my properties, the exponent can come out as a coefficient, so I have 1/3 log a of x y to the fourth z to the 9th. Now I can recognize that there's division here, and remember the second property said that division is the same as subtraction, so I'm going to say that's 1/3 log base a of x y to the fourth minus log base a of z to the 9th, and make sure that you're keeping up with the 1/3 being multiplied across all this stuff. And then I can do the similar game from part A. I can break up the x and y, so I have log base a of x plus log base a of y to the fourth minus log base a of z. And why don't I actually go ahead and multiply out that 9 in front, right? Because I can pull out the 9 because it's a coefficient. And I'm almost done. I'm going to distribute the 1/3 across, and I'm going to pull out the 4 out of this middle term. So I have 1/3 log base a of x plus 1/3 times 4, so that's 4/3 log base a of y minus 1/3 times 9, which is actually just 3 log base a of z. And now it's as simple as I can get. I can't do anything else to it. And there's my answer. And notice that the stuff inside the logarithm of both these examples, by the time I'm done, are very simple. So expanding the logarithms will help simplify what's inside the logarithm. Okay, now let's go the other way. Let's start with the bottom and move up to the top, where we're going to use properties of logarithms to condense. And you can see in part A, I have a long expression, and this time I'm going to bring it together. And so remember, things like coefficients, so like this 1/3, will get pulled in now as an exponent. So here, we'll start there. I have log base 2 now of x to the 1/3 power, right? I could bring in the exponent. There's nothing I can really do in the second part. And let me just say here, sometimes people are tempted to break up this as like log 2x times log 2, 3. That's a misuse of the property. You cannot do that. You can't break it up when it's added on the inside of the logarithm. But I do have an addition outside, so I'm adding 2 logarithms, so I can bring those together as multiplication. So I can write this as x to the 1/3 power times x plus 3. Now, depending on your teacher, they may want you to write this as the cube root of x times x plus 3, and they may even want you to distribute that. I don't know. I'm fine with either of these, to be honest. I just want to see that you can use properties of logarithms to bring it together. All right, so let's try that on part B. This time I have ln x squared y minus ln y minus ln x. And remember, what is ln? That's just log base e. So this is just another logarithm, not really a big deal. Okay, now with a subtraction, it can be easy to get confused. I recommend starting from the left and going right. So we're going to use this, we're going to treat this subtraction first because remember, subtraction turns into division. So I have ln of bringing in the ln y, I have x squared y divided by y minus ln x. Okay, and now I can say bringing in the ln x, I have ln x squared y over xy, right? Because I was dividing by x, the same as multiplying by 1 over x. And then now notice that actually this time some stuff simplifies in the inside. The y's cancel and 1x cancels. So I end up here with ln x. And that's as simple as it gets. And there we have it. Okay, so now notice with condensing, what happens is the inside may not simplify that much, though on B part it does. But you're taking these long logarithmic statements and you're simplifying them down to one, right? So condensing does that. It brings them down to one statement. Where expanding, like in example 1, will simplify what's on the inside of the function, but it'll expand out the statement like that. I hope this makes sense. Guys, go over these. They're not hard to memorize. They're very useful, and once you see it, you see it. So just keep practicing. Let me know if you have any questions. I'll be glad to help, and thanks for watching.